Okay, so today we're going to talk about arithmetic and geometric series. So it says here, find the sum means to add up, of the first 8 terms, and here's my sequence so far, 1, 3, 5, 7. So notice that my sequence is going up by 2, so the next number, I need 8 terms, I have 4 so far, I need 4 more. So the next number would be 9. And then 11, 13, and then 15. So there's my 8 terms, so I want to find the sum. So I take all the numbers, 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15, and I add them up. So the sum of my numbers, the sum of my arithmetic sequence is 64. Okay, find the sum of the first 5 terms. So I don't have my terms. I have a formula here. A sub n equals 3 times 1.1 raised to the n minus 1 power. I need the first 5 terms. So I'm going to start with a sub 1 being my first term, a sub 1. So it's 3 times 1.1 raised to the 1 minus 1 power, which is 0. So it's 3 times 1.1 to the 0 power, and that's equal to 3. Now I need a sub 2, my second term. 3 times 1.1 raised to the 2 minus 1 power. So it's 3 times 1.1 raised to the first power, which is equal to 3.3. A sub 3, the third term. 3 times 1.1 raised to the 3 minus 1. So that's 3 times 1.1 raised to the second power, which is 3.63. A sub 4 is 3 times 1.1 raised to the 4 minus 1. So that's 3 times 1.1 raised to the third power, which is equal to 3.993. And my last term, a sub 5, is 3 times 1.1 raised to the 5 minus 1 is 3 times 1.1 raised to the fourth, which is equal to 4.3923. All right, you add them up. And when you add them up, you get 18.3153. So this was a geometric sequence that we added up, and I got 18.3153. So what these are called, this first one, since I'm adding the sum of numbers that are increasing by adding 2, that's an arithmetic series. And the second one, which I have a common ratio, right? My common ratio is 1.1. And that is the sum of a geometric series. All right, so let's see what it says down here. Get rid of this. Okay, so it says the arithmetic series. To find the sum of an arithmetic series. All right, now, this formula is not on the formula sheet. So the formula for an arithmetic series is S sub n is equal to n times a sub 1 minus a sub n over 2. Now, of course, you don't necessarily have to use this formula. You could write out all the numbers and then just add them up. But it's sometimes easier to use this if you have a lot of numbers. So anyway, this would be the sum of n terms. N is how many terms you're adding, number of terms adding. This is your first term. This is your nth term. Okay? Now the geometric series, which is to find the sum of geometric sequence, this is actually on the formula sheet, so you don't have to memorize this. You're going to have to memorize this if you don't want to have to write down all the numbers and add them up. Okay, so this is the sum of n terms. This one here, a sub 1 is the first term, obviously. R is your common ratio. And n is the number of terms you're adding up. Okay, so let's take a look at the first one here. It says, find the sum of the first 5 terms if a sub 1 is 3 and r is 2. Now, of course, you could come up with all 5 terms, right? Just keep multiplying by 2 and then add them up. All right, but let's try using the formula. All right, so let's just come up with the formula. So it's S sub n equals a sub 1, which is 3, minus 3, which is a sub 1, times r, which is 2, raised to the n power, over 1 minus the common ratio, which is 3. So I want to add up the first 5 terms. So I want S sub 5, which is 3 minus 3, times 2 raised to the 5th power, over 1 minus 3. So 1 minus 3 is, oh, sorry, not 1 minus 3. It's actually 1 minus 2. That's my common ratio, my bad. So 1 minus 2 is negative 1. And the numerator, you could just plug in your calculator, you get negative 93. So negative 93 divided by negative 1 is 93. So if I had written this out, 3, comma, 6, comma, 12, comma, 24, comma, 48, that would be my first 5 terms. And I added all these up, I would get 93. Okay, so let's take a look at down here. Looks like a review right here. The population of ants is growing at a rate of 8%. This is an exponential growth. If there are 160 ants in the initial population, find the total number of ants to the nearest whole number after 6 years. So remember, that's y equals a, sub 0, times 1 plus minus your rate raised to the x power. So since it's exponential growth, it's y equals a sub 0 times 1 plus the rate raised to the x power. So my initial number of ants is 160 times 1 plus my rate, which would be 0.08 raised to the x power. And I'm looking when x is equal to 6. So that would be y is equal to 160 times 1.08 raised to the 6th power. That you could just plug in your calculator. To the nearest whole number would be 254 ants. Okay, and that's it, and I'll see you guys tomorrow in class. Have a good night.